Hello and welcome. Happy to be here. Quite a big stage, so also a bit intimidating, but people here are so super friendly, so I think it'll be fine. A little bit about me. I'm a staff engineer at Lunar, a challenger bank, a neobank in the Nordics. I joined Lunar back in 2016. Nearly from the very beginning. Fun fact, I'm old enough to have started programming on a Commodore 64. What I believe in, I believe very much in continuous learning. And I'm always skeptical about dogmas. So maybe that's why I really like DDD, because DDD is all about learning, and it's not very dogmatic. So I consider myself a DDD practitioner, but not an expert. Lunar. So what is Lunar? As I said, a neobank founded in 2015 with the clear mission to disrupt the banking industry in the Nordics, try to do banking in a different way. We think of ourselves as a technology company running a bank. So we're sort of attacking the banking from the technology side. We went live as Lunar Way, as we were called in the beginning, in April 2016. Back then, piggybacking on top of a real bank, one of the older banks. But in 2019, we received our own banking license, and we were going to build our own banking core and be a bank for real. We went live as a real bank, then just called Lunar, in the first quarter of 2020. And now we have around 750,000 customers across Denmark, Norway, and Sweden. Just a few tech highlights. We've been cloud native from day one, so that's also pretty special for a bank running in the cloud. We've used event sourcing since 2019. We have lost count, but approximately 300 services running in our Kubernetes production cluster. And of those, a third is probably using event sourcing. So the basis for this talk is the bullet that was highlighted on the previous slide, the one about us getting the banking license back in 2019. When we were to build this banking core, we asked ourselves, what characteristics do we want from our new banking system? And I did a talk about that also in 2020, early 2020, here at the DDD Europe, in the first edition of Event Sourcing Live. It was about 2 weeks after we had went live, so not very much experience. But we had an idea about what we wanted to do. And we chose event sourcing as parts of the foundation due to this vision we had that, well, when building a bank, you deal with people's money, then you suddenly want to know what's going on in the system at all times. So traceability at all levels was what drove us to event sourcing. Since if something happens and you need to figure out what happened, it seemed like a very good idea to have an event source. You can just go in the event source and see what happened in the system. And when looking in page 1 of any event sourcing book, the first example, it's always an account. So, of course, our banking core should be event sourced. So, what I'm going to tell you now is how did that then go? So the last 4 years of experience using event sourcing, and during that also being actually good at doing DDD. Because, as I said, we chose event sourcing before choosing DDD. So DDD came sort of, we had been doing a bit, but not very much. It came along the way. So that's also what I'm going to talk about. So what is a bank? I guess you all have an idea about that. We're all interacting with our banks whenever we use our mobile payments, or a credit card, debit card. But there's, of course, a lot more to a bank than payments. It's a heavily regulated industry. There's a lot of subdomains with complicated relations and interfaces between each other. So I just tried to throw in some of them on a core domain map. You shouldn't think much about where they're placed, except for the core and the supporting. So there's the very bank-specific domains, subdomains, like anti-money laundering, fraud detection, loans, bookkeeping, financial reporting, know your customer, and then, of course, all the payment domains, card payments, mobile payments, trivial transfers between banks. And then more generic supporting domains that we find elsewhere as well, authentication, authorization, identity, and customer subdomains. So what I'm going to talk mainly about in this talk is the account and the transfer. The team I'm a tech lead in is responsible for implementing and maintaining the integrations into the national clearing systems. So whenever somebody moves money in or out of the bank, that's what we're doing in my team. So, with the scene set, a little bit about the agenda. I'm going to go through 3 challenges we've met during this. The first one is the challenge of the long event stream, particularly the account. The second one is getting the model right. So that's the modeling, the DDD part of it. And finally, how we have built, or how we are building, resilient applications using event sourcing at the bottom. So I hope you'll all get something out of it. If you're new to event sourcing or want to try it out, maybe you can use this to not make the mistakes we did. If you're already doing event sourcing, then either you can be reassured that you were not the only one making a lot of mistakes, or if you didn't do mistakes, you can be reassured that you are smarter than us. And either way, it's nice. So let's get into it. Yeah, the name Lunar. It was chosen by our founder because he thought of building a bank like a moonshot. It seems to be a difficult task. So everything we do is space themed. So I've generated some AI images sort of related to the themes. So the first challenge, the long event stream. Yesterday, or Wednesday, I think, Jackie Reed said, it's best practice to keep your event streams short. We can certainly testify that having long event streams comes with extra complications. So that's what I'm going to talk about. So, I need to know a bit about the audience. How many have real-life experience with event sourcing in production? Ooh. Okay, a bit less than half. Okay. The rest of you, you'll get a short crash course in event sourcing, and those with the experience you can either just lean back and see if you have the same understanding of event sourcing as we have. So the account is the example here. What we do in event sourcing is, first of all, event sourcing is a persistence design. Doesn't have anything to do with event streaming. It's how we persist things. So for the account, instead of storing how much money is on the account, is the account open, the actual state, the current state of the account, we store all the events that has happened in the system since beginning of time. So in this case, the account is opened at some point. Later, money is deposited in the account, and later again some money is withdrawn. And at some point, very long way to the right, the account is closed. But of course, the state is also relevant. So how do we get to the state? How do we say something about whether the account is closed, opened, suspended, whatever state it can have, and what's the balance? Well, we can always calculate the state. So at the beginning, after the account is opened, the balance is 0, then it's 100, and when we withdraw money, it's 50. So in functional programming terms, it's just a fold left from the 0 state and then applying all the events in order. So we can always calculate it. We don't have to persist this state. What about writing? How do you do a consistent write in event sourcing? Well, let's say we have 2 events on the event stream at this point, and then a command comes in, command to withdraw 50 whatever units of currency. What we do is we read all the events on the event stream, project that into the state. In this case, it only has 2 properties, the status of the account and the balance. So here the account is open and the balance is 100 of euros in this case. Then we can validate the command against the state, and if the command is valid, we actually have funds, the account is open. We can then write a new event to the event stream. So this will be event number 3. Easy. But what if somebody else beated us? So between we read the first 2 events and we wrote, or we wanted to write event number 3, somebody else beat us to it. Another command somewhere else in the system came in and actually succeeded writing event number 3 instead. Then the state we use to validate the account against is no longer consistent with the reality. So in this case, our write must fail. That's the very simple version of doing event sourcing. The right side of event sourcing is nothing more than this. You just have to be able to implement this. What we did back then in 2019 when we started doing this, we looked around. We primarily a Go shop, so we had already been using Go for years at that point. So we looked for tools, libraries to do event sourcing in Golang. There wasn't really anything we could trust. There was a single library developed by a single person that we didn't want to build our bank on top of that. We also looked for products. We actually looked at Event Store. But at that point, the cloud offering in Event Store wasn't as good as it is today. We would have to maintain it ourselves, figure out how to deploy it into Kubernetes, etc. So we actually chose to implement a library instead and maintain that ourselves. On top of well-known technology, Postgres. So we implemented this using Postgres, and having a SQL database beneath, then this consistent write here actually becomes very easy. It's just a unique constraint on the event numbering. Somebody wrote event number 3. I want to try to write event number 3. Well, you're not allowed to do that. Okay, so that was the crash course in event sourcing. Now you can ask yourself, what happens if the event stream is long? Well, this happens. And it happened pretty fast, actually. So the orange part of the graph is the 95 percentile of load times when we wrote to the account. So the customers having a lot of activity on their accounts, it started taking a long time to load them when we had to do something on it. Especially when a credit card transaction comes in, we need to be pretty fast at answering that. So we could see that we actually didn't have very much time to fix this. So what do you do? Introduce snapshotting. So the basic idea is pretty simple. Instead of loading all the events from the event source, at certain intervals you do a snapshot of the state, store that, and then when executing a command, you only have to read the snapshot plus additional events. So it goes like this. A command comes in. We start out by reading the snapshot into the state, then reading any additional events that has been written to the stream after the snapshot, and then just proceed as before. Validate, write new event, and we're done. Except that we, of course, have to update the snapshot. That shouldn't be done in the same transaction. That should happen outside of the write. Don't want to spend time on updating a snapshot while also doing the write. So we implemented this in the platform, and this is then what came out of that a month later or something like that. The drastic drop is where we deployed that, and now we get consistent low load times because we just have to do a read of the snapshot and then at most 100 events. We're snapshotting every 100 events. So if you're doing long event streams, this is a must. You need to be able to do this. Okay, another thing about long event streams. What about the state? So this is a pretty naive example of what the state of an account could look like. It has an ID, timestamps for when it was opened and closed, and then there's a map of reservations. So when we get a request to reserve some funds, that's what we do with credit card or debit card transactions. You reserve some funds on the account, but we want that to be idempotent. So when executing or handling that command, we start out by checking in the map, have we already seen this reservation? If we have, well, then just return, nothing new to do here. Otherwise, publish the funds reserved event onto the event stream. That's, of course, also not a good idea. What if you have hundreds of thousands of reservations on the account? For normal customer accounts, it's not a problem. That map doesn't, the size is okay. But for the very active, for example, business accounts, if there's a lot of transactions on the account, then this can easily become a problem. So when you try to load this into memory, your application instance is just killed because you're using too much memory. Yeah, so that map is unbounded. So what can you do? Well, we can pull out the view of the reservations, provide that view projection in the command, and then just do exactly the same. When we execute or handle the command, we look up in the view and return if it already exists. So we pulled out the unbounded map to some SQL-based table instead. But as we all know, every solution has a trade-off. Neil Ford emphasized that yesterday. So what's the trade-off here? Well, this projection is eventually consistent. So when you do event sourcing, everything you do after something has been written will be eventually consistent. So how can we handle that in this case? There are ways to handle this. Actually, what we're doing, not exactly on the account here, but elsewhere, we're keeping only the tail, the latest tail of stuff happening on the account. And then when we evaluate the command, we need some way to make sure that there's an overlap between the tail, the latest that we keep in the state, and the projection we keep in SQL. So this can also be solved. Finally, event evolution. This is all the events we have on the account event stream, or the event types in production. So we have 78 event types on the account event stream. Most of those are now deprecated old events. I'll get back to that in a short while when talking about modeling. Most of them are due to bad understanding of the domain to begin with, and we simply model it wrong. But when it's written to the event source, we are sort of stuck with it. We have to be able to load it, an event. We cannot just throw it away because it's there and the event source is immutable. So how do we handle that? Well, some of the events are actually also versioned. If you see, yeah, I don't know if you can read it, it's not important. But some of them have v2 or v3 or v4 afterwards. So you need to be able to do upgrades. Here's an example. Not exactly from the account, but you get the idea. Let's say, in our case, when we started looking at going into the other Nordic markets, Norway and Sweden, figured out that we had actually forgotten stuff in our events. So we needed to version this event and include some information about the clearing, which clearing was this about, and what country. So all the events we had were about Denmark. So we needed to be able to sort of upgrade these events and have information about the country. So we built in an ability to upgrade events on the fly. So we read the old event from the database, and then the library is configured to look for these upgrade methods. In this example, we can just fill in default values for the Danish events. It could also be more advanced upgrades where you actually have to look up somewhere else to get the value of a field. We also support that. So that's also really essential when you have long event streams like this. Which then, so learnings from working with the long event stream. Avoid it, if possible. It comes with extra complications. If you do it, snapshotting is a requirement. And look out for this unbounded state. That's going to bite you at some point. Model evolution is inevitable. When you learn and understand more about your domain, and this has a tendency to mess things up. So be diligent about how you model. Especially keep the number of events low. So, modeling, getting the model right. As I said in the beginning, we didn't have much DDD practice when we started this. It came sort of while doing this. So, of course, we did a lot of mistakes. In the beginning, when we went live, this was how we had modeled a transfer on the account. So a user executes a command, and we thought of this as happening on the account. The user wanted to initiate a transfer, so the command enters the account, bounded context, validate, check everything, and then start this transfer. So that means sending it off to the Danish clearing when we only were in Denmark, wait for a response from the clearing, and then change the reservation into a posting on the account. So on the event stream, that looks like this. So the four events inside the boundary here is actually events having to do with the transfer. First, an initiation event, then after we have validated the command, a funds reserved event, then after we have sent it off to the clearing and it comes back as a success, transfer completed, and we turn the funds reservation into a transaction posted event. There's, of course, a lot of problems in this. First of all, single responsibility. We now have the account event stream that both has responsibility on keeping track of the account ledger, how much money is on the account, handle reservations, etc., but also execution of these transfers. So those two things are now very tightly coupled. And furthermore, in order to determine idempotency of a transfer, if we get a transfer request again, the account now also has that responsibility. So we actually realized this pretty quickly. So already in the second quarter of 2020, a few months after going live, we changed this. So we pulled out the transfer domain from the account event stream, instead having a short-lived event stream representing the transfer. So more or less the same events, but on a separate event stream. Now, the transfer interacted with the account more like as it should, as a ledger, asking for permission to reserve some funds, and when the transfer was completed, then changing this into a posting instead. However, there was still a very tight coupling in that specific event. It's called transfer transaction posted. So the little word transfer, it actually knows about that this is a transaction coming from a transfer, and it also contained information coming from the transfer, like who was the receiver, what message was sent with this transfer. So still some tight coupling. When we were to enter the Norwegian and Swedish market, we started that around 2021. And at that point, DDD had become something we did, a practice we were using. Whenever we were starting something new, we did domain discovery, we did a lot of event storming to understand the different elements of the Norwegian clearing to begin with. The Norwegian clearing is old, so there's a lot of capabilities that we needed to understand. So we had a lot of sessions doing discovery, event storming in order to understand this, and later on process modeling. So I've tried to do the essence of one of those just for the transfer on this slide. So it begins just as before. A user initiates a transfer. It enters the transfer subdomain, and we initiate the transfer on the transfer event stream. The next step is then to call a command on the account ledger to reserve funds, giving rise to a funds reserved event on the account ledger event stream. Then we had separated out at this point the screening subdomain. So after reserving funds, we screen the transfer. That happens in a separate subdomain, giving rise to a screened event on the transfer event stream. And then we can send it off to the clearing through a clearing, some kind of adapter towards the clearing. When it comes back as cleared, Yeah, the clearing said yes, we moved those funds to the other bank. We can then finally capture the funds on the account ledger and post the transfer on the account. So this event storming session we then use to change how we have modeled our landscape. Oh yeah, I forgot one thing, because we of course also have to be able to tell the user something about how did this go. So the last part is a read model, being able to tell the user about the success or failure of the transfer. So we use that to model, remodel our service landscape. Before, the transfer subdomain was actually still inside the same service as the account. We now pulled out the transfer to a separate bounded context implemented in another service. All our services they have a published language. So we publish public domain events. I just learned yesterday that I shouldn't say integration events. That's what we actually call them, but it should be public domain events. And all of our bounded context has an open host, an API for other bounded contexts to interact with. So this is actually the picture we have today as well. There's a domestic transfer service implementing the actual execution of the transfer, and it's interacting with the account ledger truly as an account ledger. So the picture when looking at the event streams is very similar to before, except that now the transaction posted event is a real transaction posted event. It's not a transfer transaction posted event. So the account ledger is now used as it should, simply something keeping track of postings on the account. It knows nothing about where does this actually come from. All the information about the actual transfer entity comes from the domestic transfer bounded context. The actual execution is implemented as side effects. So I think, no, just one more thing before I'll talk about side effects. So what we did there was splitting up one bounded context into several. We've also been using DDD to look at inside the bounded context and try to model things better inside. So a transfer, of course, errors happen, timeouts happen, network glitches. So while executing this transfer, we also need to be able to handle these errors. So inside the transfer bounded context, our initial transfer aggregate had events on the event stream that had to do with this orchestration. So the less orange of the events on this slide, funds reservation retried and screening timed out, has to do with error handling. So we have events that are mixed business domain events like funds reserved, transaction posted, mixed with things having to do with orchestrating, retrying a funds reservation, retrying a screening, handling errors like this. And again, more than one responsibility for this single entity. Yeah, so business and orchestration. So what we've done last year actually is to split this. So now we have a transfer aggregate that only has what is relevant for the business side of things. So all the events, the public domain events coming out of the transfer domain comes from that aggregate. And then we have one or more sagas that represent the actual execution of this transfer. So in this here, there's an execute saga, but if a transfer is returned from the receiving bank saying, well, we don't know this account, don't know how to handle that, we get it back again, then we have to repost the funds on the customer's account. That is handled by a reversal saga. So when looking at the event streams, it looks like this. So now the transfer event stream is at the top. When the transfer is initiated, a side effect of that is to start this execute saga. So the execute saga will come into life and do its work, reserve the funds, screen, etc., send to clearing, capture the reservation, and then it dies. The transfer event stream still exists. So if the transfer is returned from the receiving bank, a reversal is initiated on the transfer, and that then triggers the reversal saga to handle that and post the money back to the customer's account. So, yeah, learnings about getting the model right. As Marcus just said, you should prepare to get things wrong. Evolution of your model and understanding is inevitable. While you're working on it, you will learn a lot more. So you should prepare to actually evolve this. After doing initial event stormings, the model is not done. Keep using DDD practices. When you've done the initial event storming and you have a picture of the model, keep doing this in order to enhance your understanding of the domain. And of course, that's trivial. If you're using event sourcing, then use what you have learned from the event storming in the event source. There should be a very clear one-to-one correspondence between what you model in what you found out in your event storming sessions and what you actually store in your event source. So, this brings us to the next challenge: how to do resilient applications using event sourcing. The answer here is event subscriptions. So, writing to the event stream is rather trivial. It's pretty easy to do. But what about read models? What about side effects? How do you actually do this? This is very much like the pops-up pattern in messaging. You have a producer producing something, in this case events, on the event streams. Then you should have the ability to set up consumers of these event listeners with a handler that can perform some action. And this has to come with semantics that we're familiar with from other platforms, for example, Kafka. At least once the delivery, and it should be in order. The last part, bullet 2, is really important here. Order matters a lot when reading from the event stream. We use that all the time. We use it for internal read models, for example, for item potency, as I talked about earlier. We use it for external read models, the query side of CQRS. We use it to execute commands both inside our bounded context, but also outside. We use it to publish the public domain events, update metrics, and the process orchestration, the sagas, is actually also built on top of this. So, how do you do that? In our case, we have built that using an outbox pattern. So when writing to the event stream in the same transactional boundary, we also write some information to an outbox. And there's then a reconciliation loop that reads whatever this information is. I'll get back to that shortly. Reads the events that needs to be processed and gives them to the handlers to do their work. It sounds pretty simple, but this is actually the part of our library we've had the most problems with. There's some timing here, right? You want to be able to do this pretty fast. When an event is written, it matters how fast handlers will get these events. For example, when doing critical stuff where you need a process to be reasonably fast, it matters how fast this is. So what's inside the outbox? In our first implementation, which actually came a bit after we went live, so we didn't have this in the beginning, which meant that we couldn't actually trust stuff being processed correctly. But in the first implementation, we actually just wrote the event to the outbox as well, one record per event. And the reconciler then did a row-level lock on this record in order to guarantee that no one else was processing this event while the reconciler was doing it. Remember, we're of course in a multi-instance setup here, so you wouldn't have several instances processing the same events. That meant that we had long transactions spanning the handlers, and as we all know, DB locks are really bad. So that led to lock congestion, instances blocking each other, trying to handle the same events, and a buildup of a queue in the outbox with unhandled, unprocessed events. So we needed to do something about that. So the second implementation, which is the one running now, we wanted to get rid of these DB row-level locks. So instead, what we do now is we partition the work based on the event stream ID and assign partitions to instances. We still have a pull-based reconciler, but it's now lock-free, since each instance of the services will only handle a certain part of this. We're using consistent hashing, so they'll only handle a part of the hash ring. This has immensely improved throughput. When we look at our metrics, now the outbox is almost always empty. But this reconciliation loop is pretty tough on the DB. Some services will have this reconciliation loop happening every 100 milliseconds. The transfer service, for example, it's really important that we get stuff processed fast. Other services, it really doesn't matter. So for where it's not critical, we can set this reconciliation loop the frequency to, for example, 1, 2, 3 seconds in order to not put this load on the DB. So, learnings about event subscriptions. This is absolutely necessary. You need this in order to be able to build resilient applications on top of event sourcing. To do projections, to have read models that you know actually have the correct data in them, this is an absolute requirement. You have to do it in a way where it's independent of writing new events. I've heard about other people actually updating projections in the right of writing new events to the event stream. Don't go there. Actions must, of course, be idempotent. That can be a challenge if you are integrating with APIs where, this is not the case. We have an integration partner that has a very unreliable API, which is certainly not idempotent. So you have to figure out a way to handle that if you're doing that as a side effect of writing to your event stream. You have to embrace eventual consistency, of course. And you must be able to support event replay. Let's say there's a new feature requirement and you need a new read model. You have to be able to populate that. We have built that into, we're using the Spotify model organization-wise. So we are also using Backstage and building our own plugins. So we have this as a plugin in Backstage. You can go in and say, for this service, this event stream, and this handler, give me all the events. It's a super great tool to use for a thing like that. And finally, this guaranteed ordering is really, at least we have struggled with that. So we are not completely done yet. We're looking into turning it around, so instead of a pull-based model, finding a way to do a push-based model instead, so we don't have to query the database all the time. So that actually gets me to the end in good time, I can see. Some overall learnings. Building complex systems with event sourcing at the core as a persistence design requires mature tooling. But when you get there, it's a really, at least that's our opinion, it's a really great way to build applications. If I were to do it again, I would certainly look around for existing tools. Events.db, for example, has a very good cloud offering now and comes with all of this built in. So you want to get a fast start, look for existing tools. Information grid, I didn't know about that, but take a look at that as well. It looks like a really neat product, also for doing prototyping, quickly getting up and running on with event sourcing. I want to say another thing about this. Event sourcing is really a liberating design. The right side is uniform data model you have across all of your services, using just a very simple schema with events in a JSON blob, in our case in the Postgres database. And you have extreme freedom on the right side. On the read side. You can create all the read models you like. For example, what Rebecca talked about this morning, DB migrations. So in traditional persistence design, you have to always think about how do I do DB migrations. In event sourcing, on the read side, it's trivial. Instead of doing DB migrations, we just fire up a new read model and throw all the events at the projections, and then you have your new read model. So it's really, really liberating in terms of working with the database. And that's maybe also trivial. It's a perfect fit with DDD. If you do DDD, event sourcing is really a good choice. And finally, jumping into event sourcing without a really good understanding of your domain I can testify is not a perfect idea. You should really have a good understanding of your domain, otherwise you are going to be changing a lot of what you did. The other side, DDD learnings. Don't think you can do it without domain experts. We started out as a startup that wanted to disrupt the banking sector. So due to that, we didn't want to talk too much with the old banks, but they actually know a thing or two about how to do banking. So bringing people in that actually know about this domain, yes, that's a very good idea. Otherwise, like us, you'll be doing a lot of changes to your models of how to do things. And at the tail of that, evolve your understanding. To me, DDD is an agile process. It's something where you continuously learn and improve your understanding. And you're never finished with that. Yeah, and then use the model and the language as much as possible, both in your implementation down to the level of variable names, but also in the organization. We're using the Spotify model, as I said, with autonomous teams, and we are centering all the teams around specific domains to reduce friction between teams, etc. Yeah, that actually brings me to the end. So, thank you.
All right, thank you, Thomas. There is still time for Q&A, so Rory will throw the mic.
Hello, thanks a lot. I'm new to DDD, even if I'm from an old bank.
Okay.
So I would certainly like to join and have a conversation together.
Yeah, sure.
It's more a suggestion than a question. Like you said, old banks have a lot of experience, and there are also banking models, architecture models in the market.
Yes.
Did you ever had the idea to look at it and how to use it?
Yes, and we are actually using the...
Beyond?
Yes, exactly.
Beyond?
Yeah, we're using that model. It came late that we actually discovered that there was this very big model of banking domain. Fortunately, we had actually ended up modeling much of it in the same way. But it's definitely worth looking at.
Do it.
You showed on a slide you were writing events to your event stream and also to your outbox. Does that mean your outbox is an exact copy of your event stream, or do you write different events to the outbox?
Yeah, in the first version, we actually wrote the event to the outbox and then deleted it again after we had handled it. Now, in the second implementation, the data is not in the outbox. It's actually just a single record per event stream. So the ID is the primary key in that table. And then we're keeping track of how far we have come. So there's a watermark. So we're just updating the event number when writing, and the reconciler then keeps track of if the watermark is below. That's the new implementation.
Okay, thank you.
In the beginning, you showed that you have the snapshotting or compacting at each 100 events. How you come up with this number, 100?
It sounded as a good number.
Have you considered smaller or bigger? Or?
Yeah, I think it came about when we actually started seeing this problem. We looked at well, how many events are there on the streams which is actually taking a long time to load? And that was way above 1,000. So 100 seemed, if there's 100 events, that we can easily load that quickly.
To do that already.
Got it. Thank you. Hi, Thomas. Happy Lunar customer here.
Fantastic.
I had a question about if you guys had tested out the Akka model, which could help with the serialization and also the outbox locks and stuff like that. And if so, what issues have that caused you?
Yeah, actually when we started doing event sourcing, the very first version of our event sourcing library used the Akka model. There's a framework which also has a Go version. I can't remember the name. But the coding model is very uncommon in the Go world. So we actually chose to do it differently. So no futures, because it's so uncommon to work with in Go. And a lot of our developers felt very estranged by the Akka model. I have experience from Scala and Akka, so I'm very fond of the Akka model, but yeah.
Thanks.
I'm really curious, how did your test and unit test look like when you did the migration from the Outbox version 1 to version 2 and you removed the DB logs?
That's a very good question. Yeah, what we started out doing when we did this was we built a test harness. So in order to be able to prove that we did stuff correctly also in the second version, we built also a performance test kit, but also a functionality test kit that we could use on exactly the same setup, but using the new Outbox. Then we simply ran this to prove that, well, we're still doing the right thing. And then, of course, the separate components of it is unit tested.
Anybody else?
Thanks for the enlightening talk. You talked about the event and how it helped you, but I'm curious to know about the migration phase. How did you do the migration? Because normally when you are migrating from synchronous to asynchronous, it is really challenging. So how did you had the migration? It was Big Bang or other sort of migration?
Yeah, so you're thinking about when we actually first started doing event sourcing.
Exactly.
Yeah, we were quite lucky because we got this banking license. So we were switching from the old system where we piggybacked on a real bank to actually implementing our own banking backend. So there was no migration, except for actually migrating the users. So that part was more easy because it's just taking the accounts with a single balance and then initializing the streams in the new system with the correct balance. So there wasn't really any complicated migration, at least at the persistence layer. There was a lot elsewhere in order to get the customers moved, but not there.
Thank you.
All right. Thank you so much. We need to wrap up. Thank you, Thomas. This was a lovely session.